Welcome back. So in addition to inequality notation, where we saw that our inequality can either be less than or equal to, greater than, or greater than and equal to, in addition to this, we also saw that we can have a solution graph, or an interval graph is also called, but we can also express our answer in what's called set notation. And in this video, we're going to talk about what set notation is, and it's actually it's a little simpler than it might seem at first. So let's say we want to write the following inequality in set notation. So we have x is less than or equal to 1/2. So our set notation is going to look like this. We're going to have an open bracket and a closed bracket at the end. And in the middle, it's going to look like this. And I'm going to read it out as we write it. This is read, the set of all values x such that x is a real number less than or equal to 1/2. Okay, so once again, it's read, the set of all values x such that, the vertical line means such that, x is a real number that is less than or equal to 1/2. Okay, we actually use set notation almost exclusively when we're dealing with proofs and higher mathematics, so this is actually a really important concept. So let's go ahead and do a few more. Let's say we want to write the following inequality in set notation. We have x is greater than -1. And we want to write this in set notation. Well, we saw how we do it. We just write the set of all values x. The brackets actually are read the set of all values x such that x is a real number that is greater than -1. Okay, not a whole lot to it. Let's do a few more. Let's say we have the inequality x is less than 7/3. We want to write the set of all x, the set of all values x, such that x is less than 7/3. Let's look at the next one. Let's say we have x is greater than or equal to 4. And we want to write this in set notation. So we have the set of all values x such that x is greater than or equal to 4. So the set of all values x such that x is a real number greater than or equal to 4. All right, these are actually very simple once we get familiar with them. Most people actually get a little disturbed when we see this set notation, but once we know how to read it, and we'll do a few more examples to practice that, it's actually nothing to write home about. So let's say we have the inequality x is greater than -4. X is greater than -4. So we want to write it in set notation, so we say the set of all values x such that x is a real number greater than -4. All right, let's go ahead and do one more. Let's say we're given the inequality x is less than or equal to -8. Let's go ahead and write that one in set notation. We have the set of all values x such that x is a real number. We're not dealing with irrational numbers. A real number that is less than or equal to -8. Okay, now well, not in this course, but in another course, we might do a course on logic and proofs later on, but we'll see that the set of x is not always the set of real numbers. It could be a subset of that, like the set of all rational numbers or the set of integers, and we actually have special notation for that as well. But right now we're just dealing with real numbers to just get a handle on what set notation is. So we'll be using these a little bit more in our section on linear inequalities. So I just want to get you familiar with them. Go ahead and review this video a few times just so we can get familiar with how set notation is read. And in the next video, we'll be going over interval notation. So I'll see you soon.